Ah, yes. Yes, excellent. This equation came from this part. That part came from this, not the 9. And this is only true from bound 2 onwards. So this part of the equation is only true when n is bigger than 2. So the way to correct for that is to replace this n with n minus 1. Because this is only true when n is bigger than 2. So you can correct for that by saying n minus 1. And then you will get the exact right answer every time. So, the formula for total distance is 9 plus 2 and then you can use this to find the height of the fifth bound. I'm not going to worry about that right now. Questions? Okay. So 33 is even better problem.
Oh, we're done?
Yeah, that's it. This is the key. If you can get this, then you're fine with the rest. You just like plug in 5, 6, whatever they want, whatever bounce they want. That's not the problem. So 33 is where things will get very interesting and very applicable to real life. 33 talks about, and it's actually pretty true to what I'm actually doing in real life, so it's interesting. So on 33 we're saying every year I put $5,000 away in what's called a Roth. This is, for those of you who are already working, you should think about this. So a Roth IRA is a program the government set up to help encourage people to save money for when they retire. And here's what it is. Every month when I get a paycheck, I have to pay tax on the money I earned from YesPrep. If I put money in here, I do not pay tax on whatever I put in here. And when this is in the bank earning interest, I do not pay tax on the interest either. And then when I'm 62, I can take the money out, and I pay no tax when I take it out, and spend it when I retire. So the government's trying to encourage people to save money for retirement. Unfortunately, it hasn't worked as well as the government thought. But we want to see how impactful this can be. So it says every year I put in $5,000, and every year I get interest of 8%. So in year 1, I have $5,000 in the bank. In year 2, we have 5,000 times 1.08. A lot of people have been confused about where this comes from. And I'd like to show you where this comes from. So if there's 8% interest, look at the calculator. Here's how much money I have. 5,000 is what I put in, times 0.08. So I get $400 interest, plus my original 5,000. $400. $400 interest, 5,000 originally. That's the same as 5,000 times 1.08. Mathematically, to see how this works, so there's the logic. The math of this is very simple. You have $5,000, and at the end of the year, you'll have the 5,000 plus you'll have 5,000 times 0.08. Interest, original money. Factor out the 5,000, 5,000 times 1 plus 0.08. 5,000 times 1.08. So anytime you're like trying to find how much money you have in the bank after interest, you just say whatever the interest rate is plus 1 times the amount you started with. That'll always work.
Then why do you have 5,000?
So this is what I put in to start, and then at the end of the year I have the exact. I mean, this money, like, the bank doesn't take it away; still give me that. Plus they give me the interest on that money.
Oh.
And then I just factor out the 5,000. So what's left here is a 1. What's left here is 0.08. Add them up, 1.08. Eddie? Not not years. I'll show you where the year part comes in. Cynthia? Because if I factor out 5,000 from here, isn't there a 1 here left? Because 5,000 times 1 gives me 5,000, and 5,000 times 0.08 gives me this. Does that work? So in year two, how much money do I have? I have this, plus I deposit $5,000 more. Because it says I put in 5,000 every year. Then in year 3, what happens? In year 3, we have 5,000 times 1.08 squared. Why is this squared? Because this money now has gotten interest twice, from year 1 and from year 2. It sat in the bank for 2 years, this money. This money gets interest, plus I put 5,000 new dollars in. Done? Thank you. What happened? Then in year 4, this money has been in the bank for 3 years. This money has been in the bank for 2 years. This money has been in the bank for 1 year. 0.08 squared. Plus I put in $5,000 new. And we keep doing this every year. Now, let me zoom in. Let me zoom in on year 3 and then year 4. Let me zoom in on these years. So in year 3, we had 5,000 Here's year 3. If we ask to find the sum of this, what kind of sequence is this? What kind of sequence is this? What kind of sequence? Here's A1. Why? Why is it geometric? Here's A1, A2, A3. What's the common ratio? 1.08, folks, wake up. Wake up, folks. If you don't understand, you've got to ask. We're going to have a question like this on the exam when we have closed notes exam, for sure. R is 1.08. So this is the sum, adding, of a geometric sequence. Eddie? How did you know it was 1.08? To go from here to here, you multiply by 1.08. To go from here to here, you multiply by 1.08 again, hence the square. No, but we're just looking for the R right now, the ratio. Here's term 1, term 2, term 3. We need to find the common ratio. So if I wanted to find the sum of these without adding them all up, I would say, well, Sn equals A1 Brandon, why is the R 1.08?
Cause it, keep adding each year.
Adding what?
1.08.
I'm adding 1.08,
Whatever you multiply it
multiplying it by what?
by the amount.
By the amount?
Like you keep like, it's like continual kind of thing.
So maybe we want to say we're multiplying 1.08 by the previous term to get the next term.
Yes.
Okay.
Right, that is correct.
Okay. So the formula for the sum of a geometric sequence is a1 times 1 minus r to the n over 1 minus r. Except n would be 3, because this is year 3. So to find the amount of money in year 3, we just say S3 equals 5,000 times 1 minus 1.08 cubed, all divided by 1 minus 1.08. Questions on this? So here's year 3. Now let's look at year 4. I don't care about the number right now. I just want to get to the formula now. Shanley?
Why do we do year 3 as year 8? We can solve it out without.
Because I'm trying to illustrate a point, though, that's a general formula. So in year 4, please note, we had 5,000 times 1.08 cubed plus 5,000 times 1.08 squared plus 5,000 times 1.08 plus 5,000. Again, we have the sum of a geometric. Here's a1, here's a2, here's a3, here's a4. And again, r is 1.08. So we would say S4 equals 5,000, a1, times 1 minus 1.08 to the 4th power, all over 1 minus 1.08. Every year is just the sum of a geometric. Every single year is just the sum of a geometric. So if you wanted the amount of money in year n, Sn equals 5,000, that's a 1 minus r to the n over 1 minus r. And with this, you guys can find in year 25, year 5, year 10, whatever year you want to find. Questions on this? Okay. Let's continue on then. So they ask us to find how much, when will we have $1 million in the bank? So let's find that. Hmm? 2 minutes, solve this problem on your own.